This is Test Long and Prosper, talk about the Spock testing framework and our journey from our old test setup to using Spock to test our code. I'm going to show some examples of actual tests for our production code. But first of all, I want to ask who in the audience is a tester? Like, okay, a few. And is there anyone actually already using Spock? Okay, yeah, I guess. Yeah, you're in my team, so I hope so. Okay, so about me, I'm Cas Plattel. I work at bol.com since October 2016 as a software engineer in team 4D, and we we're a team of 3 developers and a tester, and we work in the financial processing part. The plaza bit of bol.com is becoming larger and larger, both in absolute numbers as well as in percentage of turnover of bol.com. And we're basically dealing with the financial part of it. So it used to be the case that there were multiple invoices for different kind of services which retailers would use at bol.com. But we've kind of combined this into one invoice, and that's where we work on, and what we're testing actually, if what we build actually holds true. So this is the example service I'm going to talk about. It's the RTN, it's the Retailer Transaction Service. And when we got it, we had to build a lot of features on top of it. And it's actually doing some sort of logistical events. So let's say a shipment happened, and then of course customers pay for a product, and we have to put this money or transfer this money to retailers in the end and invoice this. So that's basically what RTN does. So let's say a shipment happened, we pay out money to the retailer, but if a return happens, we have to reclaim money for the retailer. And then there's all kind of other logistical events like stuff from the warehouse, we have to charge for a retailer. And that all happens in the RTN. And at the end of the month, we basically invoice this to a retailer. But the way this, so this was all working, but the way this was tested was kind of creative, I guess. So for instance, let's say a message would be pulled off from AQ, and a certain field would be missing. We would apply a certain fallback and then process this message in RTN. But the way this was tested was, instead of just doing this like in a unit test, was that we would spin up the application, would spin up some Docker images for a Postgres database, an Oracle database, some queues, a box, the whole shebang. And then we would put a message on the queue, which would get read off of it with the value lacking, and then we would apply the fallback. But instead of just stopping there, we would propagate the whole flow throughout our business logic, and then even until the database, and then basically assert if something had happened, which is basically an end-to-end test. So that was a functionality tested in this way. And then we would build a new feature. For instance, instead of invoicing everything in this month, we would invoice some stuff in the next month, which is basically some other part of RTN, which would like take a few hours to implement. We would run our tests, and then we would see 400 tests fail. And we were like, okay, where to begin with this? Because then you would look up these tests, and then there would be a test failing related to a fallback applied from a message in a queue, and you were like, okay, I got no clue what's going on. So the test setup wasn't working for us. So we had basically 2 options here. Either continue with this and then spend a few hours implementing stuff, and then spend 2 days in fixing tests, which weren't really contributing to anything, or just throw everything away. And I think this was kind of the advantage of using microservices, because it's more easily to say, let's throw everything away and start over. Because that's basically what we did. Well, we didn't throw everything away, of course, but some unit tests still exist, I guess. But that ended up, or for us, this ended up in being kind of like a greenfield situation, because we had to redo our test set. So we kind of like determined what would be the test frameworks which we would like, or would provide the most value to us. So there's JUnit, and usually JUnit tests look something like this. Very technical, kind of chaotic, because there's stuff going on, some assertions, some setup, very technical. But the advantage is, of course, you directly test your code. There's almost no boilerplate. But yeah, you can't really. You kind of can describe the functional part if you use comments and stuff, but it's kind of lacking in that way. And also doing parameterized tests, which we do a lot, is kind of clunky in JUnit because you have to do it with annotations and then include arrays and variables inside the annotations, and then, well, much to be desired, I guess. So it's okay, but not perfect. And then there's Cucumber. We actually had a lot of Cucumber tests, which we kind of ditched. So usually, but this is like an example of a Cucumber test. So you have these gherkin files, the feature files, I should say, which correspond to certain step definitions underneath. And all these sentences actually execute the code behind it, the glue code. Yeah, so there are quite some advantages to using Cucumber because you can actually document your stuff. You can actually read back, like, what is the feature, what was the goal of it. And ideally, you sit down with your business stakeholder, write down these feature files, and then actually code behind it. Of course, at least we never did this because business, business is business. But you can easily parameterize these tests, like you just saw. They're in these gherkin files. You have these nice tables in which you can actually repeat your tests. But there are some drawbacks, and for us, these were quite heavy. There's a lot of boilerplate going on in Cucumber, so you have these step definitions defined per step in your feature file. So you have kind of a shadow administration of what you're actually doing, and it's easy to create shared state between these sentences, because sometimes you set stuff in a certain step def, and then the next step def kind of works with this. So it's easy. It doesn't have to be like that, but it's easy to tangle stuff up. Especially if your code base grows and you want to reuse certain sentences and step defs throughout tests, it can get quite hairy. And then there's finesse. We only had a limited amount of finesse tests actually, and we quickly killed them. You have this wiki interface, and it's kind of the same as Cucumber, but older, I guess. The same pros, I guess. You have an actual description of what you're testing. But there's even more boilerplate, and there's like, it kind of pushes you towards this end-to-end pattern, at least that's what we noticed. It's kind of clunky, because you have these conventions about the odd number of columns do this, and then the mapping from certain tables to methods leaves much to be desired. So at that point, we basically brought in this guy. A teammate of ours had already been using Spock at his previous job. And he was kind of like, okay, this kind of worked for us back then. So we started out as an experiment. So all the new user stories, we would write test code with Spock. And we would end up replacing all of our unit tests and integration tests with Spock. So why did we actually like it? We liked that it didn't really have a lot of boilerplate. So it's actually code first. It has a clear syntax. You can still use it as documentation. In a way that you actually describe the functional steps you're doing throughout your test. It runs on top of JUnit, so it's actually still very fast. And it's behavior driven, so it's a given when then structure. And then there's some pro and cons to Spock. I guess a pro would be Groovy. So it's easier syntax. It's kind of like Kotlin compared to Java. You have some nice syntactic sugar. Iterables are more easily to use. You have higher order functions like map and filter directly on your list instead of using the streaming API. So that's kind of neat. But there are some downsides, and most noticeably, it's Groovy. So it's instead of statically typed languages like Java and Kotlin and Scala, it's actually runtime, so dynamically typed. So at runtime, you figure out, okay, these types mismatch, or methods cannot be found, etc., that kind of stuff. So that's actually the largest drawback for us for using Spock. At least the most troubles we ran into were related to us not being Groovy experts, or being too lazy because we rely on static type checking, I guess. Also, renaming and IntelliJ doesn't really support Groovy all that well, was our experience, but that's more tooling, I guess. So yeah, this is what a Spock test looks like. A simple Spock test. You basically define your test, so similar to like a method name, for instance, in JUnit, and then you have these standard way of describing your test with a given when then. And in the given, you kind of declare your initial situation, so some initialization of objects, some mocking perhaps. In the when case, you actually perform the action you want to test, so a method call or calling an endpoint or that kind of stuff. And in the then part, you do your assertions, so you check if the result is what you would expect it to be. Then there's JAB, which is a layer on top of Spock. And we have a limited amount of services who have a front end, but the ones who have a front end, we test with this nowadays. And JAB is actually, you define your test similar to as you do with Spock, so given when then structure, but JAB actually integrates with Selenium, so it actually does the clicking on your front end, filling in some fields, that kind of stuff. Yeah, so I'll show some examples of, let's see, actual Spock tests which we use. Let me first mirror my screen. That should work, yeah. Okay, so this is an example of a simple unit test. So it's just similar, very similar to how you would do it in JUnit. You define your class and you extend specification, and this is a Spock thing. And in the setup, you can initialize, in this case, or class on a test, because we're just doing some unit testing. And then you have, you can write your tests. So in this case, we have a test with a given when then structure, which I just explained. So we define a method here, some description about what we're actually doing in a functional way, and then actual parameters. So I'll get back to how you can parameterize this test. So in the given part, you define some initial variables. In the when part, you actually execute your action. So in this case, we call a method. And in the then part, we do our assertions. So we assert in this case that a certain exception wasn't thrown. I guess that's something you might test. And then in this specific test, we have a where case. This is optional. And this is the way you can parameterize your test. So in this case, this transaction type is a Java enum. And we retrieve all its values, which is an array of things, I think. And for each of these elements, we execute the test. And we put it in the parameter transaction type. So let's say this enumeration has 15 possibilities, then this test gets executed 15 times with this variable. Yeah, so we can actually see this. It's running for each of these values. And a neat thing I think about Spock is that this transaction type can actually be referenced in your method signature, or sorry, in your method name, and then it gets filled in your runner text. So that's neat, I think. And here's an example, more elaborate, about how to test or write a Spock test with multiple parameters. So you actually have, it's falling off the screen, but there's actually more parameters going on there. You have the same when-then part, so the given is optional. In this case, we do not have any preconditions we have to explicitly set. We do some assertions. And in the where case, we actually build up a table, similar to how you would do this in Cucumber. And then the test is executed for each of these table rows. And it fills in these variable names or column names map to the parameters used in your test. So this way you can actually use multiple parameters in your test. And then there's an example of an error flow, I guess. This is the test where we expect a certain exception to actually be thrown. So this thrown and the not thrown, which you just saw before, are actually Spock out of the hood, of how do you say it? Predefined method helpers or helper methods. So you just you can use them and actually even get something like the exception from it, and then assert on, let's say, the exception message or something. So it's quite neat. Then how do you mock stuff with Spock? So in this case, we have defined a certain object as a mock. In this case, return port. We've asserted as mock, and in the setup, we use it in some class we're going to test. And again, you have the given when then structure, so some stuff going on. In the when case, we actually do our action. And in the then part, we actually assert. So in this case, we want to verify stuff on the mock. And in Spock, this kind of looks like this. So you have some sort of numeric value, then an asterisk, and then the mock, and then the method signature on which you want to verify. In this case, we use a wildcard, so we don't specifically test or assert on the value in which it's called. Just want to make sure that the mock is actually called exactly one time. And here's an example. If you want to verify that something isn't actually called, you just switch this number to 0. Then it asserts that it should never be called when you execute the when statement. Similarly, you could, of course, increase this number if you want to verify if it's being called 10 times or something. Okay. Then an example of a Spock test which uses argument capturing. So this is quite elaborate. We have again the given when then structure, and here you actually see the strength of that you can actually document your tests. Is you use the end word, which basically means you could leave this out, and then you would just have a very long given block. But with the end, you can kind of document the steps you're taking. And in this case, we actually want to verify again on a mock that it's being called to a certain method, but we also want to assert on the actual parameters of the method. So in this case, we apply a closure in which we kind of do argument capturing. So these two arguments here, the transaction and the tag mark in this case, are actually the two arguments which have been passed on to the mock. And we explicitly assert on the values of these arguments or of these parameters. And that's kind of a gotcha, or at least took us some while to figure this out. That in this case you actually have to explicitly state assert, because if let's say the assertion would be on a root level, so let's say I would verify something like this isn't equal to something else. If this evaluates to a Boolean, then it will Spock will automatically assert it because it's on root level, so on the leftmost level of your code. But if it's like inside a closure, inside an if branch, that kind of stuff, then you have explicitly include assert, which led to some surprises for us. Then the last example I want to show is actually of a JEP test. So this is a test in which we test our front end. So like I said, it's actually basically the same. You have a Spock test with a given when then. And in this case, we have some sort of submit form, which you fill in some values, and then the submit button should switch from being disabled to being enabled. So in the given block, we do some mocking and some setting. And in the when block here, we actually fill in some fields. In this case, the retailer field gets filled in with a certain value, some sort of string or ID. And then in the end, we assert something. But of course, this retailer field has to be defined. So where is this actually on the front end? So for JEP, you need some boilerplate code. And in this case, for the page we're currently at, you have to, for each page you see, you have to create some boilerplate code. In this case, you just define your fields or your UI elements, and you use some Selenium selectors to actually define how to pick this element from your UI. Yeah, so there's some boilerplate, but other than that, it's very little. So that's what we like. And on normal Spock test, there's even no boilerplate at all. Yeah, so there are some quirks, as I said, to Spock. Definitions can only be done in the given block, so you really have to define all your variables and your stuff over there. And then mocking and stubbing is kind of something you have to get the hang of. It's slightly different than how you would do this in Mockito, for instance. And the argument capturing is kind of clunky. So which I just explained that you have to do it on root level instead of when you do it inside an if branch or inside a closure. But for us, most quirks were related to Groovy. So getting the hang of that almost helps you with most of this learning this stuff. But I think it has been really beneficial for us because it's this neat in the sweet spot between JUnit, which is very technical to test stuff with, and QCOM, where you have a lot of boilerplate code, but you can still document your stuff. And this one is, I think, almost exactly in the middle, where we can still document or very technical tests. So we have successfully tested our backend and frontend and unit and integration tests with this. So we're actually quite happy with it. So I would recommend everybody to at least give it a try and see if it works for you. And other than that, thank you for your attention.
Are there any questions?
Yeah, where do you run these tests? At build time and
Build time, yeah.
Okay.
Yeah, similar to JUnit, for instance.
and about reporting, is it very easy to extract all your steps that you have or scenarios
yeah,
that you
I
have
think there was a
defined?
possibility for it, right? Yeah.
Okay. Okay, cool, thanks.
Yeah. So reporting is possible. Sorry.
In your examples, I saw some annotations like happy flow and error flow.
Yeah,
Are-
sorry. That's those are not Spock stuff. That's basically.
Are those mainly like classifications, or do they actually do more than
this
that?
is just purely syntactical, without any stuff going on there. It's just for us that we know, okay, we're testing happy flow, or this is testing error flow, because we tend to only test happy flow, and of course you should always test error flow just as many times. So that's a helper for us to actually, so it's not a Spock thing, unfortunately maybe. But
I also have a question.
Sure.
You were saying that Groovy is a bit of can be a double-edged sword.
Yeah.
Have you also looked at tools like in Kotlin that might do the same thing? Or
Yeah.
something
I've
like that?
actually a few days ago I read into Spec, I think it's called, which is also a specification testing framework. Which might actually serve our purpose. So might actually give that a go, especially since some of our services are in Kotlin. I don't know. We might experiment with this. Maybe an upcoming project.
Present it next year, maybe.
Yeah, that's a good one.
Nothing else? Okay. Thank you, Cas, for your presentation.
Yeah, thanks.